Hello, in this series of videos, I'm going to provide an introduction to a high-level programming language that is a domain-specific programming language extensively used in engineering and science to solve computational problems, known as MATLAB. Now, the syntax and structure of MATLAB you can also use in Octave, which is an open source equivalent. So let's start. MATLAB. Now, when you open MATLAB, you're opening a program. So MATLAB, when we talk about MATLAB and MATLAB programming, number one, MATLAB is a program. Number two, is a programming environment. Number three, it is also a programming language, which is that has a specific syntax and a specific structure like any other high-level programming language. Now, it is a domain-specific programming language as opposed to being a general-purpose programming language like C or C++. It's more akin to R as a statistical programming language. In this case, MATLAB is a domain-specific programming language, high-level programming language, interpreted like Python as opposed to compile like C or C++. So we just launched the MATLAB program, and what we see here is the command window, the workspace, and the current folder. Now, to start programming, you want to type edit, or here click on new script. So if we type edit, now we have the editor. This is going to be the text file where we code, where we write our programs, our scripts, or where we create our own functions in the context of functional programming. So let's start with that, and the first thing that we want to learn is how do you write a comment. Put that percent sign, and you do 2% signs, you actually create a cell. Now, introduction to programming by Matteo Boy. So let's start. I'm going to create another cell here, and let's go over the common elements to high-level programming languages. I'm going to create an itemized list, and if I do this in the comments, there is some functionality that you have in MATLAB where you can publish your script, and it has some formatting output, so this is useful. So actually, let me write here a little bit. So what's high-level programming language? First, high-level is a language with abstraction higher than assembly. Okay. Couple other definitions. What do we mean by, well, we could say that this is interpreted as opposed to compile, although you can also compile the MATLAB scripts. And what are those common elements? Well, when we are programming in high-level programming languages, we work with variables, we work with concepts like data types, data structures. Right? We need to store our variables, our data, somewhere in memory. Once we have those variables, we need to do some sort of input-output, typically, input and output. Basically, this either we get data from keyboard, output into the screen. I'm going to say keyboard, a file, maybe you have a file with the data that you need to load. It may be a device if you are doing some hardware interfacing, as well as outputting the data, output to screen, file, device, etc. So, okay, we have variables, we have input, output. What are other things that are common to all high-level programming languages? Well, we have mathematical and logical operators or operations, meaning once we have variables and data in those variables, we may want to add that data, subtract, divide. Really, all the basic arithmetic operators are available in the high-level programming languages, and then depending on the programming language specifically, you may have other functions and other operators to operate with that data mathematically as well as logically. Is this equal to that? As well as doing the typical and or statements, etc. Okay, so you have data. You can get it from the keyboard, file, or device, output it from the keyboard, file, or device. You can do some basic mathematical operations and logical operations. But that just will be a sequence of statements, very basic program, if we didn't have conditional execution. This is basically an if-else type of statement. If this logic condition happens, execute this part of the code. Otherwise, else execute this other, right? So that's conditional execution. In programs, we are automating tasks, and so typically we have repetition. That's looping, loops, or iteration. And in loops, those are typically, so if this is the if-else, well, if, else if, else if, else, this typically you have a for loop or the while loop. Okay, so you need to be able to iterate. Then what do we have? Functional programming. You want to modularize the code and be able to create your own functions to solve particular sections of the problem that you're trying to solve. Objects. If you are in object programming language. And then there are always native and specialized libraries. What in MATLAB we call toolboxes. Okay? Finally, you can think about, is your programming language capable of doing graphical user interfaces and things like that? So in essence, these are common elements to all programming languages. And so I recommend that when you're learning a programming language, or if you want to learn other programming languages fast, just initially learn the syntax for these elements: variables, input, output, mathematical and logical operations, conditional execution, repetition, meaning iteration, functional programming. If it is an object-oriented programming language, how do you work with objects? Then go in depth. If it is a domain-specific programming language like MATLAB, you want to go over native and specialized libraries, and then perhaps how to create GUIS. So with that, incidentally, these are all comments. If I were to run this file, I have not saved it yet, so I have to give it a name. Put it in a particular directory. I'm going to go to my teaching directory, and I'm going to say, okay, I'm going to call this programming intro P1. If there is a file, you can replace it. And then we have two choices here. Either we want to add that directory to the path, so when we call that script by the name, MATLAB will be able to interpret it to execute it, add it to the path, or change the folder. I'm going to change the folder in this case. And notice here the folder that now we are over there. What do we have in that folder? That's me the files in the folder. And if I type that name, now it gets executed. Alternatively, I could just say here, run. Nothing happens because all what we have done was commenting. But we were commenting in a particular manner and form, so that if I were to publish it, so here I go into the Publishing tab, and I publish it, I'm creating a logbook, a published document that has some formatting to it. So every time we put the double percent sign, as you can see, and we are going to create a section. Okay? And then when we do a percent sign with an asterisk, we're going to create an automated list, right? So my objective is that as I go teaching you how to code in MATLAB, at the end of the process, if you are following these tutorials in your own version of MATLAB, you are also going to be able to create a publishable version of your script that also will be a good reference material of what you have learned, and especially the syntax of these things. So let's start with number one, variables. Okay. Now, what are variables? A variable is a storage location pair with an associated symbolic name. Okay, this is an identifier that contains some quantity of information. We refer to that as the value. Okay, so Matteo, what does this mean? And these are all comments still. Well, number one, you can think of a variable. I'm going to say it is helpful to think of a variable as a container in a program that holds information. That is, let me elaborate here. A container with a data value a container, I would say actually, in which data value can be stored inside the computer's memory. Okay. Now the purpose is to label and store the data in memory. This can then be used in the program, and the stored value can be referenced using the variable name. Right? So again, what is this? A variable is used to store information to be referenced and manipulated in the computer program. Okay? They provide a method for labeling the data with a descriptive name. So, okay, let's start. Now, if we run this again, we'll see that now I have another section. This is clickable for variables. Here with one column, any descriptor that I want to give to my script is there. So let's start on creating a first variable. A1, I give it a name, that's my variable name. This is the assignment. Oh, by the way, incidentally, what are some of the things that we need to keep in mind when we're creating variables? Variable concepts, so that then we can go over this. Okay, in no particular order. So number one, with variables, we should, how do we create? Creating variables. And that goes over the assignment operator, etc. The opposite of variables are constants, but it will be good to have an understanding of MATLAB constants. Before going over the constants, however, in the context of variables, it is good to have an idea of what are the data types. Data types, for example, single, double precision, char, etc. Logical. Now the concept that we have to go is over data structures. One-dimensional and two-dimensional arrays. So scalars, I should say scalars, character, one-dimensional, two-dimensional arrays, vector, matrix, etc. Constants, pi, inf, I, j, etc. And built-in functions, MATLAB functions, to work with variables. Who, whose, clear, etc. Okay, so let's publish this. This is our script of, oops, something is incorrect somewhere. Oh, that's the part that's incorrect. So let's publish this again. Incidentally, you see that it didn't create the itemized list, and that's because there is no space here. So let's create a space, and this should be fine now. There you go. Okay, so this is what I need to go in this video, since we're going to focus on variables. In other videos, I will go over input, output, mathematical operations, conditional execution, repetition, functional programming, object-oriented programming, etc. So with that, let's start with some variables here. So I'm going to create a variable, you give a name, A1. You have the assignment operator, the equal sign here. I'm going to just give a value, like A1 equals 5. Now, if I run this code now, just show I have A1 equals 5. If I click here on workspace, we can see that now there is a variable that if I hover over it, it tells me that this is a 1 by 1, it's a scalar, and the value is 5. Okay. Now, if I use a semicolon here, I'm going to say A1 equals 4, run it. What's going to happen is that we do not see the output. We can see that the variable name is the same, but the value actually changed. Variable means that the value can change, right? So in order to see what happens, I'm going to do this without the semicolon so that we see the output. We display the output and I just run the program. So A equals 4, that's one variable. I'm going to create another one. A2 equals, in brackets, so that will be the scalar. That will be a scalar. Let me create a one-dimensional array, 1, 2, 3, 4, 5, initialize it like that. In brackets, I create a one-dimensional array. Okay? And this was created by an actual listing. Now, I could have done it differently. I could have done I'm going to actually do it as an A3, 1, and use the column operator to 5, will create the same results. Notice that. Okay, that's the column operator. Let's go ahead and do another operator, A5. If I create A4 equals A2, and I put the transpose operation, I will create that row vector into a column vector. Let's see that. There you go, one is a row vector. Now, let's go over this concept of vector and array. We can think about this A2 being an array of numbers, identified as a unit in a single variable, A2, or A3, or A4. One can be a row, the other can be a column. Now, when we are talking about a one-dimensional array, you can think of about that as a vector. Now, a vector is a special case of a matrix. We are going to see this. And a very important data structure in MATLAB is matrix, the matrix. In fact, almost everything in MATLAB is stored internally as a matrix. We will see that actually. Let's do this. Actually, let me do this. I'm going to do, instead of doing this, A3, I'm going to just do the variable A. and then A4, so I'm changing this, it's going to be, sorry, A4, 1 to 5, A5, let's do A4 transpose, and A6, I'm going to say Matteo, a string. So let's run this. So let's see. Incidentally, one of the functions, once you're working here in the command window, CLC cleans the screen, but it keeps the variables. However, if I say clear, notice here that I have these variables, or there is another function that is who lists the variables that I have now in memory, A1, A2, A3, A4, A5, A6, or whos, that gives me not only the variables, but it gives me the size. A is a 1 by 1, A2 is a 1 by 5, A3 is a 1 by 1, A4 is a 1 by 5, as you can see. A5 is a 5 by 1, because you have like equivalent of 5 rows and 1 column. A6 is a 1 by 5, and then you see the class with double char, character, double character. Okay, so let's go a little bit over that. Incidentally, if I type clear, this is one of the built-in functions to work with variables. We went over whos, clear, will clear the variables. Notice here in the workspace that they are going to disappear. Or if I type who, now there are no variables, or whos, there are no variables. If I was working with in the command window, I would have to retype them all again, but I actually have them in the script. So I just have to run the script again. I'm going to type here actually CLC, so every time I run the script, it will clean the screen. There you go. So we have them all again. So let's go over A1 is just a character. If we type whos, we will see that A1 is a 1 by 1. It considers this like a 1 by 1 matrix. And it is double, okay, even though this is an integer. Now, we could say single A1, but actually we will do that a little bit later in another variable. But that's something that we could change that, and now if we type whos, notice that the answer, I didn't assign it to anything, is a single as opposed to a double type, which occupies less space in memory, 4 bytes as opposed to 8. So let's keep going. So A1 was just a variable, A2 was a one-dimensional array or a vector that is a 1 by 5, notice that, type double, 40 bytes, you can see that at the top. A3 was just the letter A, notice that, and it's considered to be a 1 by 1 matrix, 1 element by 1 element. Tells you here that the type is a character char with 2 bytes. A4, it was the same as the A2, only that instead of listing each element, we use the colon operator. Okay. A5 was A4, but we transpose it. And so instead of having a 1 by 5, we have a 5 by 1, as you can see there at the top. Here. A6 is also a 1 by 5, but it's character. Notice it occupies less space, and it's Matteo, right? A5. Sorry, A6. Matteo. And so let's do a couple of things here. Let's say I'm going to do an A7. I'm going to say is A6, and let's go 1, 2, 3, for instance. What will this do? Incidentally, you just want to execute a part of the code, like something like this. you can click here on Run Selection. Notice this. So A6 was Matteo, A7. Now I say, okay, if that's a vector composed by, so we have here A6, the first element is M, the second element is A, the third element is T. If I wanted to do 1 to 5, all of it will tell me Matteo. 1 to 4, Matteo. 1 to 3, got it? This is just like working with any other vector, or I could even do 1 to n. 1 to n minus 1. 1 to n minus 2, etc. Or I could do A6 and minus 1 to 1. That will be in reverse order. I just reverse my name. Okay, let's keep going. What else about? Let's do an A8. I'm going to do A6. Actually, let's do this. A7, just one element. For the screen, A7. One to 3. A9. Let's actually define a matrix now. 1, 2, 3. That's the first row, second row with a semicolon. 4, 5, 6. Third row, 8, 9, 10. Okay, so let's check this. So I'm going to do CLC here. Let's execute just this code first. Run selection. So as you can see, A6 was Matteo, A7, which was defined as the second element, gives you the A8, which was elements 1 to 3, MAT, A9 is our 3 by 3 matrix. So you could think of this as a two-dimensional array in some other programming languages like C. Over here, just think of a matrix, which is a very native data type. In MATLAB, it works very efficiently with matrices. Couple of other variables. Let's create here. Oh, let's go over constants. So A10, or actually, let me work with A9 first. I'm going to do A9. I'm going to say like 1 to 2. Let's pick the. This is first is rows and then columns. So first 2 rows, and let me pick the last element in the columns. Let me show you. Over here, notice I'm picking right now, in the first 2 rows, this will be the first and the second row, 1 and 2, and then I'm picking the last element in the column, so that will be 3 and 6. Notice that. Or if I did, what will be if I do and? This will be the end row and the end column. This will be element 10. Or if I do row 2 to 3 and will be now 6, 10. Or if I do row 2 to 3 and 2 to 3, I'll pick 5, 6, 9, 10. That's submatrix. Let me make sure that we have A9 defined. Okay. 5, 6, 9, 10. Okay. So that shows you how once you have a matrix defined, you can pick a particular number, a particular element, like I'm going to do the element in row 2, column 2. That will be 5. Or using the column operator, you can pick a segment. Okay. So this was, if I were to write here, scalar. Actually, let me just, yeah, scalar. one-dimensional array equals to, probably speaking, a vector. Here was an example of a character. This was an example of vector using column operator. It's an example of transpose. This is an example of a string that is treated as a vector, or a one-dimensional array, or a one column, well, in this case, one row matrix. This is how to assess an element. Those are all examples. Creating a matrix and elements in a matrix. Okay, let's run this. So this is what we have done. Let's go to publish it. Let's publish it. So what you can see is that we can see now the code and the output. So these are also going to be our notes for this programming tutorial. Let's keep going. With other things, constants. So let's do A11, pi is a constant, A12, I or j is the square root of the -1, A13, not a number. This is like if you try to divide by 0, for instance, 1 divided by 0, well, in this case you get infinite, but something that is not defined, like if you have a hole in your data, you will have another number. Another one, of course, is A14. Let's do infinity. So that was some of the constants. Now, you write them here. Notice, so you have pi, A12, the square root of the -1, notice that, and so it puts it in rectangular form, not a number, infinity. Let's do conversion of data types and the data types and conversion. By default, in MATLAB, everything is going to be floating point and it's going to be double precision. You can force a single precision if you want to save memory. So I'm going to do 817. Actually, let's do A15. Sorry. Let's say single. Let's say single A1. And let's see really what happens here. I'm going to evaluate current selection. Notice now I have A15. So let's say A1 is 4. A15 is 4. Now if I say whose, notice that A1 is a 1 by 1, yes, a character. Type is double, it's a double floating point, A bytes, but now I have this, I force to use a single for A15. Okay, that was a conversion of data type. Okay, let's keep going. Let's see. Special variables. Let's see, we can define, for instance, A16. The a variable with no element, meaning an empty variable. Let's run it. We say, notice A16, whose, what happened here in A16? It's a 0 by 0, 0 bytes. We just allocated a variable there. Notice, by the way, answer. If you do an operation, like what is ans, if I do, for instance, 4 plus 4, which will be 8, that will go into this special variable, answer. That's it. So you will see there, whose, have it there, and if I type the variable name, it will give me what do you have stored in that variable. In this case, was the result of the 4 plus 4. Okay, so that was the empty one. A17, special variables and functions to create variables. Zeros, sometimes we want to pre-allocate. We know that we are going to have data coming in, and we want to already save that space in memory, and we know the size, for instance. Let's imagine that we know that this is going to be 4 by 4 matrix, so 4, 4 of, and so we can initialize everything to zeros. Notice A17 therefore is a 4 by 4, A17, 4 by 4, here type double, 128 bytes, and if we type A17, everything are zeros. You can also initialize everything to ones. Same thing. So ones for 4. Okay. Let's see what other things. Diagonal. Sometimes another function, diag. If we say diagonal 1 to 4 is going to create a diagonal matrix in the element with elements 1 to 4. What is that? Let's replace variables and segments of variables. What do I mean by that? Let's assume the A19, and that in the A19 I'm going to create an A20, and here in the A20 I'm going to say, okay, this is A19, but in the last, actually let me do A20 equals to A19, so I have it there, and now I'm going to say, let's do A20, I'm going to say, let me change the last row, and that's the last row, or I could say the row 4 also, but I'm sorry, last row, comma, and the elements, all the elements, I'm going to change them to, let's say, a vector of ones, 1 to 4. Let's see what this does. Notice these two statements. First, I'm going to create my A20 equals to A19. It's the same. And now what I have done is, okay, let's pick the last row, that is the last row, and let's assign to that last row a set of ones. Or let's do also now A20. I'm going to do for all the rows, so now it's all the rows, I'm going to do the last column and I'm going to say this is 1 to 4. Let's see what that does. Over here in this column, now we're going to have 1 to 4. Notice that. Okay. Or we could do a segment. Let's do something like A20. I'm going to do, okay, let's pick this element. That will be row 2, and this element, row 3. Actually going to add, so 2 to 3, comma, and then 2 to 3, and I'm going to replace that with zeros, or actually with the matrix I want, like 1, 2, 3, 4. Notice what I'm doing here. 1, 2, 3, 4. So this is replacing. Okay, some additional, special functions to work with variables. One will be the function length. Like if we say length of A2, if you have a vector, length, notice A2 was a 1/5 vector. If I say length of A2, it will tell me that it has 5 elements. A more powerful function is size. Size of A2 will tell me that it is actually a 1/5. Or in the case of size of my matrix, which is A9, it will tell me it's a 3/3. Of course, who that we saw, whose, as well as clear, that I'm not going to use it here, since otherwise you just will clear all the variables. So let's run this. And now the script, which is our most basic program, we run it, and we at least allocated these variables. Well, this is a very simple program, right? In order to have to solve more complex problems, we need to be able to get input, perhaps from a file, like a lot of data, and plot it and do whatever we want from a device. Typically, we're going to need to do some mathematical operations and logical operations. We need to do conditional execution. If this happens, do this, otherwise do that, repetition, etc. As well as engage in functional programming, meaning divide and conquer, solve particular items in our program through functions, etc. Where a program like the one that we did may be useful is, for instance, if you wanted to define a significant number of variables, like all your engineering constants. You could create a program like edit my constants. It doesn't exist. Let's create it, and you could start saying something. Let me just open here a book with constants, an engineering book. Imagine that okay, so this will be my program. My constants, my con, defines useful constants in the workspace. And you will maybe provide some more documentation here. Then we'll say, okay, fundamental constants. And you may want to type, okay, Avogadro. And you write the number, that's like 6, that's 0.24e to the 23. That's the Avogadro constant. Let's imagine, that's not a comment. Velocity of light, that may be 2.998 e to the 8. Gravity, 9.807. H Planck constant, 6.625 e to the minus 34, etc., etc. You could do unit conversions, etc. Now you run this, and what you have done, actually, let's do CLC, clean the screen, clear, clear all variables, run it, and let me make sure that they do not print out. And now you have a variable. So you imagine a situation where there is a set of constants that you always work with, and you may want to have them defined. Those are your constants: Avogadro, velocity of light, gravity, Planck's constant, Boltzmann constant, etc. All the ones that you use, or conversions, and then you just run your program by either run it or type in the program name, my constants, and they appear. Notice that you have them now in the workspace, and so if I say C light, that will be it. Now in the next video, we're going to say, what will be the C light if I multiply times 2? There you go. You can do operations with this constant. So stay tuned for the next video. Effectively, something like this is what we just have done, right? So we went over variables at a high level, some of the data types. Just remember, most MATLAB works with doubles. You can force a single, etc. Data structures, you're going to see that a very, very important data structure in MATLAB is what in other programming languages, like in C, will be a two-dimensional array. Think in MATLAB, this is just a matrix, and you're going to have all the matrix operations well-defined, etc. And so now that we have this, in the next video, we will go over input and output to start, as well as mathematical operations. Thank you.